So, welcome everybody. You guys made it to the Microsoft track. My name is Donald Hessing. I'm the head of Microsoft within Capgemini. And next to me, we have Arin Roy, who is the lead architect at Capgemini within the DCX practice. Now, Arin will talk you through Dapr, which is a very interesting technology which can help you to ease the development and, let's say, the architecture around distributed architectures. Now, I'm not going to steal a lot of time from Arin, so Arin, the floor is yours.
Thank you, Donald. So yes, welcome everyone. And let's get started with Dapper. Before we dive into Dapper, I think let's see what are we trying to solve here today. So typically we have made, let's say we made a choice that we will be building an application with microservices. But before we start delivering business value, what are some of the dependencies that we need to solve now before we actually start doing it? So we need to answer some questions like, okay, where is the application going to run? Do we need to target specific infrastructure? Is it limiting portability that we need to rewrite our application if we need to do it? We need to make a choice for a platform or a framework to use. And then typically these platforms or frameworks come with narrow language support. They also have tightly controlled feature sets which limit what you can do with those platforms and frameworks. And then, of course, with microservices, you end up with a lot of integration points and targets that you have to take care of. Things like tracing, configuration, secret management, third-party API integrations, message queues. And then in no time, your application is coupled to specific services and SDKs. But all of this, you need to make those decisions up front. But can you start delivering business value without answering all of these questions? Yeah, that's where Dapper is going to help you. So what is Dapper, or Distributed Application Runtime? Dapper is, the official definition of Dapper says it's an event-driven portable runtime for building microservices on the cloud and edge. So let's dive in a little bit more on how this works. So when Dapper was created, it was based on certain design principles. The first one was it consists of reusable building blocks. So you, as a consumer of Dapper, are free to pick and choose what you want to use in your application. Dapper has no limitation on languages or frameworks. Dapper has a set of well-documented APIs that work across protocols, so you can use HTTP or gRPC. Dapper is inherently idiomatic, so it comes natural, so you can plug into Dapper with the tools that you are familiar with. You don't have a steep learning curve to use Dapper in applications. Dapper is platform agnostic, so you can run Dapper on a VM, on any public cloud, even bare metal or on the edge. Dapper is extensible and pluggable. Being open source, if there is a component missing, you are more than welcome to contribute to the core product and extend it. And most importantly, it's community-driven and vendor-neutral. Dapper started off as a project in Microsoft, but it has grown to be really community-driven. It's vendor-neutral. Most public cloud vendors contribute to the Dapper project as of today. So if we start looking at how Dapper is, how Dapper works, let's say we start looking at what lies at the core of Dapper. At the core of Dapper lies what we call the Dapper building blocks. And these are nothing but a set of common capabilities that we require whenever we are building microservice applications. And Dapper exposes these building blocks through a set of APIs, both through HTTP and gRPC. And what this allows us to do is you can write your microservices code in any language, code, or framework that you want to write it, so long as it can communicate with via HTTP, or even better, some with gRPC. You are able to use Dapper within your application. And all of this together, of course, runs on any cloud or edge infrastructure of your choosing. But how do building blocks actually bring in that advantage? So building blocks are just capabilities, but you need some components to actually do the work for you. And that's why Dapper components come in. And for every building block, you could have multiple implementations. So let's take an example. If we are looking at a publish and subscribe as a building block, if we want to use it, there could be a component for, let's say, from a Google Cloud perspective, for Google Cloud PubSub. And then for Azure, there could be a component for the Azure Service Bus. So as your application, you sort of plug into the building block, and based on the configuration you have, your application can seamlessly integrate with both Google Cloud or Azure Service Bus as you feel like. So your code doesn't change; you work seamlessly. Dapr also works. How does Dapr work? So it works with the Sidecar Architecture. So if you're familiar with Kubernetes and service meshes, it's pretty similar to how that works. So for every service that we deploy, Dapr spins up a sidecar, either as a process if you're hosting it locally, or as a container if you're hosting it in Kubernetes. And what this does is that your application in itself can focus on, let's say, the business logic that it must do. And the Dapr sidecar on the side is taking care of all the communications on behalf of the application. So the Dapr sidecar can take care of service-to-service communication. It can allow your application or your service to talk to different workloads like state stores, to publish and subscribe to messaging services, or even work with bindings, input and output. So everything through the sidecar. And like we saw, so Dapr works with a set of very well-defined APIs, and each of those building blocks are represented by one of those APIs. So we can see here some examples. We have the invoke for service invocation. We have state for state management. We have publish for pub/sub. We have secrets for reading secrets. So if you sort of try to dissect this this URL, let's say the first one for service invocation, what are we doing? We are calling an endpoint/invoke, and we are passing some more metadata to it. So we say invoke/cart. So we are saying my service wants to send this request to the service cart /method/new order. So new order is the method on that service that I want to call. And Dapr, based on this this request URL, knows exactly that it has to forward your request to the service cart to the operation new order. So that's typically how it works. But all of this looks good on theory, so let's see how we can Dapperize an app. So we will take a quick look at the first app. Yeah. So what I have here is a very simple application. It's a service that accepts HTTP request, reads a query string parameter called name, and then sort of echoes back hello and the name back to the caller. So if we try to run this, so I will say .NET run. So my application is now running HTTP on 5220. If I go to my request file and I say, okay, localhost 5220, send the query string name build, and I send the request. What do I get? My service echoes back with hello build. But how do we Dapperize this? So for Dapr, we need to have the Dapr CLI installed on your system, and I already have that. So what I can do is I can say Dapr run. I need to give it a name. So in this case, I will call my app Echo. I need to say which port the app is running on. In my case, it's 5220. And I need to say at which port should the Dapr sidecar run. So that's, I say 3500. And then I tell Dapr that to run my application, execute .NET run. And here it goes. A lot of logging. So my application started again at localhost 5220. What's interesting to note here, Dapr says application was discovered on port 5220, and Dapr sort of connected to it, and the sidecar starts running on the side. So what happens now if I send a request to make my old request to the port 5220, my service still works. But I asked Dapr to run the sidecar at port 3500. So can I make the same call to that port? So I have a request here that goes to port 3500, passes a query string parameter name with Dapper. I give it a header, Dapper app ID echo. So this tells Dapper which application it should route the request to. And I make a send request. And it fails. Some issues. Sorry. Oh, this is not good. Something goes wrong with the invocation. But yeah, what we can see is, Dapper introduces a trace parent. So this is like a trace ID. So Dapper inherently works with distributed tracing. This header is introduced, and yeah, this. My bad, just a moment. Yeah, and this helps with. So we can also try to now invoke this service with a simple curl call. I am hoping that that would work, or probably not. If I say curl. No, for whatever reason, I think my DNS is messed up and it's giving me trouble. But yeah, let's move on. I have some more demos coming up, so it would be interesting to have a look at those. Okay. So hosting of Dapper. Dapper can run both as self-hosted on your local machine, where Dapper starts the sidecar as a process side by side with your application. And Dapper can also run on container hosting environments like Kubernetes, where Dapper runs the container side by side with your application container in the same pod. So when you deploy your Dapper application to Kubernetes, Dapper also sort of spins up a few system pods that we see here. If we look at some of them, so there's the Dapper operator, which is managing the component updates and the Kubernetes service endpoints for Dapper, so where things like state stores, PubSub, etc. We have the Sidecar injector, so for Dapper-enabled services, this is going to spin up the sidecar side by side in the same pod as the application. We have the placement service, which is used for actors. It creates mapping tables that map actors to the pods. And we have the sentry. So the sentry is typically managing the MTLS communication between the services, and it also acts as sort of a certificate authority within that scope. So yeah, we look at an application that runs on Kubernetes. So this is how the application structure. So we have application that has a React front end, and it has 4 services. One is a GoMux application that is working as adder, so it does just addition. We have a .NET application that's doing subtraction. We have a Python that does multiplication, and a Node application that does divisions. So if we take a quick look at the code. So what I have here is, so there's subtract controller. So this is my .NET application that does the subtraction, my Go application that's doing the addition, my Node.js application, like I said, does the division, and the Python application does self-multiplication. So how easy is it to install or deploy Dapper with my application? So on if I go to my CRD, all I need to do is add the set of annotations to my CRD for it to enable Dapper. So let's look at the annotations. So the annotations, we say, okay, Dapper enabled. So that tells the sidecar injector to start the Dapper sidecar. When this application is deployed, we give it an app ID. We have the app port on which the application is running. And we have a Dapr config, which is a set of configuration that tells how certain things should work for Dapr, things like tracing and configuration and those things. So if we now try to deploy this, so I can simply say kubectl apply. So my deployments to Kubernetes are created, and now if I try to do Kubernetes get pods, so what we will see is we have a pod for the front end, the addition, the division, multiplication, and subtraction. And when you see that they are all running two components. So like we saw in the earlier, so for Kubernetes deployment, the sidecar is injected as a container and runs side by side in the same pod as the application. So the two containers here is one for your application and one for the sidecar. We do a get pods again, and in this case, yeah, all our both containers are running on our pods. So we do a kubectl get svc to get the public endpoint for my front end. Then I quickly jump to my browser. I open this up and comes up the application. I can now say, yeah, I can do just calculator applications. I say, okay, 9 plus 2 is 11 or whatever, 8 minus 7. So I can do all kinds of application, and it works that way. If I refresh the page, there is state persistence, so I always get back the state. If we quickly go back here, try to connect to our Kubernetes cluster. If we see the nodes in the agent pool, so we see the operator, the placement, sidecar, and sentry, the system pods, and then we have the add calculator, divide, multiply. So let's say we say add, and we try to see the logs. Say run. Oh, we do a tract logs run. Oh, yeah, it is because it was zoomed in, we couldn't see it. So we saw that when we did a subtraction, this service was called, and it was logged that it did a subtraction of 7 from 8. So that is as easy to deploy an application with Dapper into Kubernetes. Moving back to our presentation. So let's take a deeper look at the building blocks. What do they do? So first is the key value state management. So what this allows your application to do is to build stateful applications by interacting with all kinds of state stores defined by the components that are available. So it can be like a GCP Firestore or even Azure Cosmos DB or even a Redis, a generic store like Redis that you can interact with. So what do we need to save state? So what we do is we call the endpoint state, and we give the name of the state store, which is configured for the component, and we send a payload to it, and that payload, where Dapper sort of sends it across to the state store and persists it, and we see here that it has been persisted. If we want to get back the state, we just simply call the same endpoint, and this time extend it with the key that we want to retrieve, and as a response, we get back the value for that key. State stores also support queries, so you can do filtered queries against the state store and get back a result, like a list of key value pairs that come back. One thing to notice here is for the keys that we see like a my app prefix to it. So what Dapper does is it prefixes your keys with the app ID, and this allows you to use the same state store by multiple applications without actually running into key conflicts. The other one is, so the next one is service discovery and invocation. So in this case, we have two applications, a Python app and a Node app. And let's say the Python app made a call or made a request saying that it wants to call the Node app at method new order, and it passed a payload. So what happens is Python app calls its sidecar with this request. The sidecar goes to the name resolution component. The name resolution, using it, it knows that that the node, it finds out where the node app is hosted. So the Python app is totally unaware of where the node app runs. So the Dapper sidecar does that resolution for it. Once it does the resolution, it forwards the request to the sidecar of the node app, which puts the request across to the correct endpoint on the node app. The node app now can do business logic that it requires to perform on that request, and then respond back the same way it responds to the to its own sidecar. The sidecar communicates back to the calling sidecar, and which sort of relays the response back to the original caller, in this case the Python app. In both cases, in this case, the node app sort of is totally unaware of who was the caller, and in the same way, the Python app, as the caller, doesn't know where the node app is hosted. The one cool thing about it is you can do a mix of HTTP and gRPC, and Dapper sort of takes care of the translation. So if your Python app makes a HTTP call towards the Dapper sidecar, and your node app accepts gRPC only, Dapper can sort of take care of that, convert your HTTP call into gRPC, and you can still have seamless communication with the other service. Publish and subscribe works similar. So you have your publisher, you call the publish endpoint, give it the name of the PubSub component that you want to use, and you have the topic name, and you pass the message that you want to publish. The Dapper sidecar, based on the configured component, sends it to that component, and you have a set of subscribers who are subscribed to those topics, and once the message is available, the Dapper sidecar of the subscribers pull those messages in and forwards it to those services and to the configured endpoints for them to consume that message. You can choose a variety of PubSub components that are supported. So you can use like a AWS SNS, GCP PubSub, or even on Azure, you can have like the Event Hub and the Service Bus. Resource binding. So bindings are typically used for triggering your app from an external source, or for your app to interact or interface with an external system. If you have used Azure Functions before, you probably know how bindings work. So they take away all the complexities of interacting with the external systems. You don't pull in a lot of SDKs from those systems to interact. They are all abstracted for you with things like even retries and failure recovery implemented for them. So in this case, if you see, we have a binding with Twitter. So if there is a tweet coming into Twitter, the Dapper sidecar is listening in. It invokes, gets the payload, forwards it to the app to do some processing with it. The other way around is output binding, and in this case, my app is sending a payload towards the binding endpoint, and which is called my database, and the Dapper sidecar forwards that request to DynamoDB. And just think of it: if you now switch DynamoDB for Cosmos DB from an application perspective, you would still be calling the same endpoint, and your application would still be able to send that workload across to the binding of your choice. Secret management, so storing sensitive information like connection strings, keys, and tokens is from a security standpoint is paramount. And when building cloud applications, we sort of end up always using proprietary secret stores based on the cloud we are hosting on. And also to interact with these secret stores, we sort of also end up using the SDKs for these secret stores. So Dapper can also abstract that away from you. So you can use the secrets endpoint and to communicate with the secret stores, and then you can seamlessly switch between secret stores without your application having to, let's say, adapt to which secret store you're using. One thing with running Dapper on Kubernetes is that you can also use the Kubernetes secret store to store your secrets and use that in your application through the same secrets endpoint. So that makes it quite convenient when running it on Kubernetes. Observability, another building block. It's sort of a built-in building block, so you can configure it, but it sort of works just fine out of the box. So you can use this to trace like the call chain across multiple services, or even see call metrics on a user service, for example. And what Dapper is doing, it's using the Zipkin protocol for tracing. So if it's quite ubiquitous, and then and a lot of those backends are supported, so you can use something like a Stackdriver or even Zipkin to get those traces in a readable format. If you combine your traces with the OpenTelemetry collector, it opens up your possibilities even more. You can export your traces to a plethora of backends, and like the Azure Monitor. You can have Datadog, Jaeger, just name it, and you could probably get your traces and metrics out there. Virtual actors is also one of the building blocks. So what Dapper allows you to do is work with virtual actors. So you can post against the actor endpoint, and the placement service, so what it will do is it will determine where to store or retrieve the data from. Dapper can also sort of offload actors when not used, and then rehydrate them somewhere else, and with the right state. So if you're using actors, you can also use Dapper for that. So we spoke about all the HTTP endpoints, but Dapper also has a lot of SDKs supporting a lot of languages. So the SDKs simply expose the functionality of the Dapper building blocks through typed language APIs. You are not forced to use the SDKs. If you are comfortable with working with HTTP and gRPC calls, you are free to do that. But SDKs, as developers, we love SDKs because that takes away a lot of boilerplate coding that we need to do. Okay, for this demo, what we have is a application that is using a few of those building blocks all together, and we will try to see how that all comes together, and hopefully this demo works. So we have a front end, which is a Blazor app, and we have a set of backend services which is namely the product, the cart, order, and notification. So what the front end is doing is it does a couple of service invocations. So it can does a service invocation to the product API to get a list of products. If the user is adding products to the cart, it can invoke the cart API. The cart API, every time you add something to the cart, it updates the state. So you see the red line going into Redis, where the cart API is doing state persistence. And once the user says, OK, I want to create an order now, it calls the order API, which persists the order into a database, and then publishes a message to the Redis queue saying, oh, the order was created. And we have a notification API, which is subscribing to that topic, order created. It receives the message, processes it, sends out an email out with the order details. So that's how our application looks. So let's look at the code. So I have used something called the project TIE. It's a .NET tool that allows us to work with microservices in the .NET world. It's a cool tool, so we can run multiple services together, including all the dependencies that we want to spin up for it. So if we see this YAML file, which defines how it works, so we see that we have an extension Dapper. We say, OK, what is the component path for it? Where do I find my config? I also say I need Zipkin. I have my services with port bindings that should be started up. And I have some more in terms of my dependencies. So I have a MongoDB where my product is hosted, and I have Redis for my state management and for PubSub. If we look at the code, we can see, so in the front end, what the front end is doing for something like, so product service. So how can we do a service invocation? So if you look at the product service, we have this one way of doing it using HTTP client. So Dapper client create invoke HTTP client gives us back for this product API, which is the app ID for the product API. It gives me back a HTTP client pre-configured for this API. I can use that to do a generic get async on this operation, get the response back, read from the stream, and get the product details out. or I can use a more RPC way of how Dapper works, using just something like a Dapper client invoke method async, and all we need to say to it is here HTTP method get, product API is the API to call, and products is is the operation we are invoking. If we now look at the cart API, go into the controller. So if you see when we are doing a cart add, what are we doing? We are getting state. So it's as simple as saying Dapper client gets state entry. I need to give it the name of the component, which is the state store. And I say, okay, what is the key? What is the key where the state is stored? In this case, cart. I can do work with it, and then eventually I can just call, say, state save async, and the state is saved automatically. The order API, we can take a quick look at how to publish. So again, very RPC style, Dapper client publish event async, give the name of the component, the topic, and pass the message body that needs to be created. One thing about Dapper, works with Cloud Events 1.0 specification. So any message that you publish using Dapper will automatically be encapsulated in a Cloud Events envelope. And then, of course, the notification API. How easy is it to subscribe to an event? A simple attribute, topic, give it the name of the component and the topic it should subscribe to. That's it. That subscription, Dapper takes care of the subscription based on this. And then once the message comes in, Dapper client invoke binding, creates an output binding towards SendGrid, and says, okay, this is the message I want to send out using SendGrid. That was it. And enabling Dapper on your application may be very cool. So here we saw we were interacting with Redis, and we also interacted with SendGrid. But if I show you my project, all I have is a Dapper ASP.NET Core library. So I do not have any SDKs or any other libraries that allows me to interact with these systems. Dapper alone is there, so I can focus completely on my business logic, while Dapper can take care of all the other interactions with systems. And getting Dapper into your MVC application is as simple as services at controller.add Dapper. There, you have it. You have your application supporting MVC application supporting Dapper. So now let's try to run the application and see it working. So I go and say tie run, because I'm going to use tie for this. So it's building my project and starting up my containers and everything. I am started. I can go to my browser now. I have the tie dashboard. So if I start the tie dashboard, I see I have all my APIs. So the 4 APIs that I have my web client. My dependencies, the MongoDB and Redis, have been provisioned as containers by tie. I didn't have to do anything for them. There's the placement service and all the sidecars with the -Dapper with it, and Zipkin for the tracing. So let's start up our application. Yep, our application starts, so it fetches all the products from the product database. I can sort of go about, say, oh, I want brown eggs, I want some strawberry, and I want some asparagus. So I have 3 items in my cart now. I can go view my cart. So again, everything is state maintained. I can just refresh my page, and it would still work the same way. I can now put in some information. Yeah, very crude, but works for a demo. And I say, go create order. Yeah, my order has been created. So what happened when the order was created was that behind the scenes, the order API published an event, the notification API consumed it and sent out a SendGrid notification. And if I bring up an email now, it's not staged, it's the time right now. You have received your order. Order number is this. Number of items this. Okay, and going back here, I will stop my application. And what we do here is, so for our components, what we had in TIE-YAML was we said our components were located at components local. So in our components, we have the definition for our state store. This is of type state Redis. We send some metadata, where it's hosted, what's the password, etc. All of these component definitions are available in the Dapr documentation, so you don't need to memorize it. Just go to the documentation and you get it. Adjust it to your liking. I don't want to show you the SendGrid because there is a secret there. It's not, it's not recommended. You should use the secret store, but this is for demos only. What I have here, I think I can use a different one to show you, because then I don't show my secret again. Oh, this one is wrong. Actually has the secret, but the key is not visible, so I think I'm safe there. Okay, so this is I have this Azure Service Bus in there. So what do I do now? I go to my TIE application. Yep, this is the right one, and I can simply say now switch this to Azure. And it's as simple as that. So I pick up a whole different set of configuration now. I can go back here, say TIE run again, and this time instead of the Redis pub sub, I'm going to use my Azure Service Bus for the pub sub, and the code should still work, our application should still work. All right, we are up again. I go here, application. My products are there. This time I add 2 products, go there quickly, put in, the order is sent. While this is happening, quick look at tracing. So if we look at dependencies and say search in Zipkin, gives us a very cool representation of how our application landscape looks like. We see a lot of traffic between the web client and the cart API, some traffic with the product API, and then with orders, and so it gives a visual representation. We can look at traces. Traces are, if we expand it, maybe should, that's the orders. If I say show, so you can see how a request went through the entire flow. So you started at the web client, you called the sidecar, it called into order API. The sidecar to sidecar communication is all GPRS, so you see the protofiles. There was a publishing, the notification API consumed it, and it sent out something. So you have an end-to-end trace of your calls already. So that was the demo. So to sum it up, I mean, we spoke of what is Dapper, but it's also equally important to understand what Dapper is not. So Dapper is not forcing a developer to embrace a programming model with strict rules and constraints. You are free to choose anything of your liking. Dapper is not a service mesh. I mean, there appears to be a lot of similarities between the general objectives of Dapper and service mesh, but think of it as Dapper works at the application level and service mesh is more something that works at the infrastructure level. And to end it, Dapper is not Microsoft Cloud Service. Yes, it was started in Microsoft, but it has a lot of integrations with the Azure Cloud Services, but it has also components for AWS, GCP, and other services. So you can feel free to use Dapper with any language, any framework, any cloud that you feel like. Some important links to end it. The Dapper website, the GitHub where the Dapper code is hosted is open source. Quick starts to help you get started. A link to .NET TIE if you're a .NET developer and you want to do it. And the code for today's demos in the GitHub repo from myself. That was it.
All right, thank you so much, Arin, for this insights on Dapper. In the meantime, we have also some questions from the audience, and the first one is from Roel. And his question is, since Dapper handles retries and failures recovery, do we as developers still have to worry about those things when we call into the Dapper sidecar from our application?
Yeah, so it's twofold, right? So Dapper is doing the retry and failure recovery on your behalf from, let's say, when you're calling a service. But in the end, it's never unending. There is a finite amount of retries that it is going to do, and eventually, if it doesn't work out, it's going to come up with an exception. So our application should be hard enough to be able to handle those situations. So yes, it takes away those complexities, but you still as your job as a developer, you should create your application that works around those exceptions.
Still need to build in some resiliency.
Yeah, of course.
Right. Okay. So Arin, I also have some questions, and in the meantime, I give the audience some time to ask some additional questions. So what I really like about Dapper is the decoupling of the infrastructure behind it, right? So we can now build an application, whether it's on Azure, on AWS, the underlying infrastructure is kind of decoupled into Dapper. What infrastructure do we need to run Dapper?
So like I said, there are two hosting modes of Dapper. So you can run it locally, or like self-hosted, but that of course means that you can run it on a VM or anywhere. And then of course, Dapper has very strong integration deployments with Kubernetes. So as long as you can run your Kubernetes cluster somewhere, I think the Dapper team has tested it out on things like Raspberry Pi and other bare metal things even, and it works just seamlessly out there. So Dapper can run almost everywhere, if I have to put it that way.
Okay, because in your example, you had a Kubernetes cluster.
Yeah.
Right, and one of the reasons why people use Kubernetes is because to be more cloud agnostic, right, and having that flexibility. But then cloud native applications tend to use still cloud native infrastructure like an Azure Queue or an Azure SQL database.
That was exactly one of the first things. So when we start with the microservices and distributed applications, we need to say, okay, what platform features are available and what do we use? And with Dapper, we sort of push back those decisions to a later stage. As developers, we start building business value up front without having to worry about, let's say, what the infrastructure is going to be, so long as I'm using a standard set of components and I can run my application anywhere.
And I think it also fits more in the microservices architecture, right? Because you don't need to have all the plumbing of the specific infrastructure SDKs that you typically use for connecting to those.
So your code is totally decoupled. You focus on the business logic, and Dapper sort of takes care of everything else for you.
All right, and then every question I always with technology, it brings decoupling, so it makes it more easy, but it also introduces a piece of infrastructure. Are there, let's say, scenarios where you say, well, Dapper is nice, but for these scenarios, it might not be the best fit?
If you look at the building blocks, they are built on the best practices and some common modules. So those components that work behind those building blocks, let's say if you take something, a component that let's say PubSub or something like state management, you have a service on Google, you have a service on AWS, you have a service on Azure. Dapper sort of levels it out with the lowest, with the common denominator. If you have to use some specific capabilities of what is offered by a service on a specific cloud, then what you should do is then start using the SDK of that. So, and the cool thing about Dapper is it's not all or nothing. You can have an application that uses only some parts of Dapper, and even like different building blocks in different services in your microservices application. You don't have to really say, I will use this and I have to use this across all my services. So it's really, it's a cool way of saying it. I read it somewhere. Dapper is Lego for microservices. That's a very good analogy, if I may put it.
All right, thank you. I think, we need to wrap up this session. So thanks everyone. Thanks Arin for this insights on Dapper. So there will be a network carousel right after this one. Please be aware our next session starts at 10 minutes past 8. Stacy will talk you through debugging remote static web apps. So still, please stay tuned and enjoy the network carousel.